Welcome back to the channel, everyone. Today we're diving deep into the science and technology of time travel as seen in Marvel's Avengers, Endgame. If you've ever wondered how Tony Stark, quantum mechanics, and a Möbius strip come together to make time travel possible, at least on screen, this is the video for you. We're going to break down how Marvel's heroes pulled off the ultimate time heist, compare MCU science to real-world physics, and tackle the big question: is any of this actually possible? Time travel is a concept that's fascinated storytellers and scientists alike for centuries, but Endgame doesn't just use it as a magical plot device. Instead, the film tries to thread the needle between wild fiction and cutting-edge, speculative science. So how does it all start? In the post-snap world, everything seems hopeless, until Scott Lang, better known as Ant-Man, escapes the quantum realm after 5 years missing. But for Scott, it was only 5 hours. This bizarre time distortion plants the seed. Could the quantum realm be the key to navigating time? According to Scott, the quantum realm is a place where time works differently. If they could somehow ride its chaotic currents, maybe they could jump back to a moment before Thanos' devastating snap. But there's a catch. Nobody has any idea how to steer through this unpredictable dimension. Tony Stark, brought in for his unmatched genius, is initially skeptical. In his classic rapid-fire techno-babble, Tony warns that trying to control quantum time travel without a precise system would be like jumping into a void. You may never make it back. He references real physics, ideas like quantum fluctuation, the Planck scale, and the Deutsch proposition, named after the real quantum theorist David Deutsch, who theorized about the potential for paradox-free time travel using quantum mechanics and many worlds universes. But without navigation, entering the quantum realm essentially means certain doom. Of course, Tony can't resist a challenge. Back in his workshop, he tinkers away, running simulations in the shape of a Möbius strip, inverted. Now, if you're wondering what in the world that means, a Möbius strip is a surface with only one side and one boundary, a mathematical curiosity that suggests loops and twists, a perfect metaphor for closed time loops in science fiction. Tony calculates the eigenvalue, a physics term for a stable solution to an equation, and suddenly, everything clicks. He's built a model for a stable time travel loop, solving the navigation problem through the quantum realm. The result? Tony's time-space GPS, a handy wrist-worn gadget for each Avenger, storing their coordinates in space and time and making round-trip time jumps possible. This GPS becomes the backbone for the upcoming time heist, ensuring everyone can return to the right reality. If you mess up, Tony jokes, you might end up as a baby or a great-grandpa in the wrong year. Exactly what happened to Scott Lang in Professor Hulk's early trial runs. The GPS, fueled by Hank Pym's rare Pym particles, now allows precise entry and exit through the quantum tunnel, a portal device that serves as the group's gateway into the quantum realm. So what's in the Avengers time travel toolkit? First, the quantum tunnel. This portal acts like a sci-fi wormhole generator, letting travelers shrink down to the subatomic scale and enter a realm where the rules of reality go haywire. Second, Pym particles. Engineered by Dr. Hank Pym, these exotic particles shrink or grow matter, acting as both the fuel and the key that unlocks the doorway to quantum space. And now, time. Since the supply is limited, every jump must be precise. Third, the quantum suits. Those stylish white and red uniforms are more than just fashion. They stabilize the wearer during dangerous quantum jumps, insulate against reality's weirdest side effects, and sync up with the GPS. Lastly, Tony's proudest achievement, the time-space GPS. With these components, the Avengers are ready for launch. But before the heist begins, Professor Hulk lays down some MCU time travel rules that break with Hollywood tradition. Alter the past, and you don't erase your present. Instead, you create a branching timeline. The Hulk's explanation pokes fun at Back to the Future, stating that time doesn't work that way. In other words, messing with your parents won't make yourself disappear. Instead, you simply create a parallel universe where things unfolded differently. The film visualizes this with the Ancient One, who shows a timeline splitting as soon as an Infinity Stone is removed. The key lesson: if you borrow a stone, you must return it at the exact moment you took it, so the timeline heals and catastrophe is averted. When it's time to execute the time heist, the Avengers split into teams and leap into the past. Each jump brings tense, hilarious, and action-packed encounters with earlier versions of themselves, the Battle of New York, and even the distant 1970s. These scenes don't just advance the plot, they put Endgame's time travel logic to the test. Mistakes like Loki escaping with the Tesseract in 2012 create tangible branches, alternate universes that can't be simply erased. The Ancient One's warning echoes here. Every intervention has consequences, not just for the Avengers world, but for countless new realities spun off by their meddling. All right, time to zoom out. How does all this compare with what real physicists say about time travel? First, quantum mechanics, the favorite buzzword in the MCU, does not actually offer a mechanism for time travel as shown on screen. In everyday quantum theory, time moves strictly forward. There's no way, based on current science, to shrink your way into a quantum realm and come out at a different time. The idea that, by becoming tiny enough, you can break the arrow of time is pure fiction, a well-constructed one, but fiction nonetheless. Where science gets interesting on time travel is in Einstein's theory of general relativity. Einstein showed that gravity is really just a warping of space and time. In exotic scenarios, like around rotating black holes, cosmic strings, or in the mouths of theoretical wormholes, it might be possible to find a path, called a closed time-like curve, that loops back on itself. If traversable wormholes could exist and be manipulated, perhaps by moving one end at near light speed, some theorists propose you could use time dilation to travel back in time. But these ideas come with huge caveats. Constructing or finding a stable wormhole is way beyond anything humanity can currently attempt, and many leading scientists believe that some built-in law of physics, sometimes called the chronology protection conjecture, would stop paradoxical time travel before it ever happens. So, Marvel's version. Not even close to these methods. There's no spinning black holes or cosmic strings, just the quantum realm. The film takes bits of quantum mechanics, bits of relativity, and fills the gaps with pure invention. The Möbius strip is a great metaphor here, a twisted loop representing the idea of a timeline that bends but doesn't break. The reference to David Deutsch's many worlds time travel adds a dash of scientific credibility too. Deutsch's real work showed that if time travel ever were possible, the best way to avoid paradoxes might be to create a new, self-consistent branch of the universe for every change. Endgame's logic draws on this. If you change the past, you don't erase the future you came from, but instead jump to a version of the world where your new actions play out. It's a clever move that sidesteps classic time travel paradoxes like, what if you killed your own grandfather? and provides a handy explanation for why the Avengers can interact with their own histories without fear of disastrous consequences. It's also a narrative device that allows Marvel to set up spin-offs, like the Loki series, in a multiverse of alternate timelines. But let's get real. Endgame isn't pretending to be a physics documentary. Even though it name-drops advanced concepts, Planck scale, eigenvalues, EPR paradox, quantum fluctuations, these are more flavor than formula. Scientists like Scott Aaronson and David Deutsch themselves have poked fun at the technobabble, pointing out that terms like Möbius strip simulation sound cool, but don't remotely map onto real equations for time travel. PIM particles, quantum suits, and time-space GPS belong purely in the toolbox of fiction. Even the energetic debates in the film, from the perils of the grandfather paradox to the importance of returning every stone, serve the story more than the science. As Hulk says when Rhodey muses about erasing baby Thanos from existence, it's just not that simple. In universe, the solution, returning the stones to their points of origin, preserves each altered timeline while allowing the Avengers their victory lap. Steve Rogers' final act, staying in the past to live a fuller life with Peggy Carter, is left intentionally ambiguous. Did he create a separate branch? Or did he somehow live out decades in secret in the main timeline? Even the filmmakers can't quite agree, but the ambiguity is part of the film's charm. In the end, what makes Endgame's take on time travel so memorable isn't how accurately it mirrors research, but how inventively it weaves big, real scientific questions into superhero drama. While you won't learn how to build a time machine from a Möbius strip and some PIM particles, you might walk away thinking a little differently about what time actually means, and why scientists are still chasing the dream of understanding its mysterious flow. Time in quantum mechanics, one way only, for now. But in imagination, in multiversal sci-fi, and in the wild equations that physicists scrawl on blackboards late at night, there are still endless places left to explore. So, where does the Avengers' time travel land us? Endgame's rules are self-consistent, if not scientifically rigorous, and they open the door for new stories across a marvelously branching multiverse. The science may be more inspiration than instruction manual, but the film cleverly gets audiences thinking about closed loops, parallel universes, and why causality is such a thorny, fascinating problem. Tony Stark's final words about Back to the Future being bullshit might be tongue-in-cheek, but the movie itself is an homage to the power of what if, the core of both science fiction and scientific curiosity. Thanks for watching. If you're fascinated by the real physics behind your favorite films, or want to learn more about the surprising connections between quantum theory, relativity, and science fiction, don't forget to like, subscribe, and ring that notification bell. Until next time, keep exploring. Who knows what timeline your curiosity might take you to next?